Getting the best from Chemistry Explained needs you to participate. So write notes, complete tasks on paper or tablet. Pause and control the pace at which the lesson goes. Crucially, complete the tasks when prompted. That means pausing the lesson, taking your time, thinking the problem through. Only when you're ready, continue. Correct your work before moving on to the next slide. Infrared spectroscopy. So, infrared radiation can be absorbed by covalent bonds, but each covalent bond will absorb infrared radiation or at a certain wavelength or energy. Achieve the absorption is via the idea that the covalent bond will vibrate. So that vibration on the absorbance of infrared radiation may be a stretch, or it may be a rotation or a bend of some sort. The point is that each covalent bond will absorb infrared radiation of a certain wavelength. So referring to the diagram on the right hand side here, pause the video and write an explanation of how it is that the atmospheric temperature has been maintained at a level high enough to maintain or sustain life. Okay, so the explanation runs along the lines of the Earth's surface absorbing ultraviolet radiation from the Sun. That ultraviolet radiation passes through the Earth's atmosphere, but the Earth's surface then re-emits that energy as infrared radiation, and that infrared radiation is at a longer wavelength than the ultraviolet radiation, which is shorter and more energetic. And gases such as carbon dioxide, methane and water, which contain covalent bonds such as carbon dioxide, such as the carbon-oxygen double bond, carbon-hydrogen-oxygen hydrogen bond, absorbs infrared radiation, preventing it from escaping into space. Only some of the infrared radiation emitted from the Earth's surface does escape into space, and therefore heat is retained within the atmosphere. So pause the video and write down some ways in which human activity is linked to global warming. Okay, so human activity includes the burning of fossil fuels to generate energy and activities such as dairy farming and the production of waste gases such as methane from dairy herds. So these two activities, for example, lead to an increased levels of carbon dioxide and methane in the atmosphere. That leads to increased absorption of infrared radiation, so less of the infrared emitted from the Earth's surface escapes into space. So that produces an increase in global temperatures. Those are the links between fossil fuel combustion and global warming. Pause the video and think of some ways in which governments, society is responding to this and trying to reduce the threat or dangers of global warming. Okay, so they're principally doing that by trying to reduce energy use, and one way that could happen is by, for instance, insulating homes so that less energy is needed to warm them up. The second principal method that's attempting to lessen the increase in carbon dioxide in the atmosphere is, of course, alternative energy generation, for example, wind power. So both of these effects should reduce in time and has reduced in time the additional carbon dioxide emissions into the atmosphere. Now within chemistry we use infrared absorption to produce information about the covalent bonds present within an organic molecule. So we irradiate an organic molecule and we produce what's called an absorption spectrum. Only some wavelengths of infrared radiation are absorbed, dependent on which bonds are present, because each covalent bond absorbs in a certain range of wavelengths. Except that, for simplicity, we don't record that information as a wavelength, we record it as a wave number, which is simply achieved by dividing 1 by the wavelength. So some examples of that would be carbon-oxygen double bond has a wave number 1630 to 1820, and so on. And you see at the bottom that the oxygen-hydrogen bond in alcohols 3200 to 3600, it will be different in a carboxylic acid. So the basic starting point for this interpretation or use of infrared spectroscopy is that if you refer to a booklet, data booklet such as the OCR data booklet, then you can use the absorption spectrum for a particular molecule to identify the types of covalent bond within that molecule. So let's look at an example, ethanol. So ethanol has bonds of interest, carbon-hydrogen, carbon-oxygen single and oxygen-hydrogen. If irradiated, it produces an infrared spectrum. These dips are actually referred to as absorption peaks. This line here is zero absorption, so this is a maximum. This is an absorption peak. This is an absorption peak. So we've got peaks here, here, and here. How would we interpret those? We need to use the data book, the OCR data book. We'll see that carbon-oxygen single bond corresponds to 1000 to 1300, and we have an absorption peak corresponding to that. We have carbon-hydrogen at 28 to 3100. Well, we've got an absorption that corresponds to that, and all organic molecules will tend to show that absorption, okay, just around the 3000 mark. And then we have oxygen-hydrogen bond in alcohols at 3200 to 36, and we clearly have got an absorption peak here corresponding to that. So, using this data and looking at this molecule, we can predict the absorptions we would expect to see. More usefully, we can irradiate a molecule, and looking and interpreting the absorptions via this data, we could suggest what bonds would be present in the molecule. Now, there is one warning on all this. There's a region called the fingerprint region. We don't generally interpret peaks, absorption peaks below 1500. However, this patterning here is unique and distinctive of ethanol. Modern computing against a database would enable a chemist to enter this spectrum into a computer for it to be analysed and ethanol to be identified on the basis of this fingerprint region, which is unique to ethanol. So all organic molecules have a unique fingerprint region, hence the term fingerprint. Let's look at another example, propanone. So here we've got carbon-oxygen double bond, carbon-hydrogen. So we're looking for two distinctive peaks. Here's the absorption peak around 3000, and we know that that is attributed to the carbon-hydrogen bond. And we have a peak here at 1630 to 1830, 1630 to 1820, and that is associated with the carbon-oxygen double bond. The rest of the absorption is in the fingerprint region, and we tend not to try to interpret that. So propanone, we can see the two absorptions that we would expect to see. So if we look at ethanoic acid, which is the third molecule really highlighted, carboxylic acid, highlighted in the OCR A specification, we'll get a spectrum like this. So we will see that we have a carbon-oxygen double bond absorption at 1630 to 1820. We will see something corresponding to 28 to 3100, but it is overlapping with the oxygen-hydrogen bond for the carboxylic acid, which has a very broad absorption spectrum. So we're not entirely certain around the carbon-hydrogen bond, except to say that all organic molecules show it. But this broad spectrum here, broad absorbance, sorry, is associated with the oxygen-hydrogen bond in carboxylic acids. 1500 and below we tend to ignore, it's the fingerprint region. However, with computerization we could enter this database into the computer and it would immediately recognize and specify the molecule ethanoic acid on the basis of the fingerprint region, which is unique to each individual organic molecule. Okay, so using the OCR data booklet, which is available online. If you don't have access to one, you need to get access to it to enable yourself to do these problems. I'm going to give you 4 molecules to choose from: propane, propanal, propan-2-ol, and 2-methyl propanoic acid. I'd like you to pause the video and suggest which of A, B, C and D is responsible for this spectrum. Please do that now. Okay, so assuming that you've worked this out, we can see that we've got the hydroxyl group present, and that is indicative of an alcohol. We've got carbon-hydrogen bonding. Notice we do not have the carbon-oxygen double bond. So part of interpretation of infrared spectra is in fact what is absent. So we have present the oxygen-hydrogen bond, carbon-hydrogen. We have the absence of a carbon-hydrogen bond in 1620 to 1830, carbon-oxygen double bond, I should say. So propane doesn't have hydroxyl group. Propanal would have the absorbance corresponding to the carbon-oxygen double bond, as would propanoic acid, so it must be C, propan-2-ol. So this is the spectrum for propan-2-ol. So choosing from the same 4, using the OCR data book, suggest which of these 4 is most likely to have produced this spectrum. Pause the video, come back when you are ready. Okay, so we can see here that we've got absorptions that correspond to carbon-hydrogen bonds, and we've got an absorption peak here that corresponds to carbon-oxygen double bond, but we don't have an absorption that corresponds to a hydroxyl group. If it was in the carboxylic acid, we would expect a very broad absorption in this part of the spectrum. So we have a carbon-oxygen double bond, we have carbon-hydrogen bonds, we don't have an oxygen-hydrogen bond, so our obvious candidate is propanal. So problem number 2 is most likely propanal. So problem number 3, same 4 candidates. Pause the video, solve the problem, come back when you are ready to go through it. Okay, so looking at this, I can see here that I have an absorption 1630 to 1820, so that corresponds to the carbon-oxygen double bond. I've got some carbon-hydrogen absorbance here. I'm going to assume that that's the case, but more importantly, I've got a broad absorption between 25 and 3300, and that clearly is indicative of a hydroxyl group, an OH bond within a carboxylic acid. So with the carbon-oxygen double bond and the OH bond within carboxylic acid, the obvious answer is D. Just to ensure coverage of the OCR specification, infrared spectrometry can also be used in a quantitative way. The more infrared radiation absorbed, the higher the molecular concentration. So for instance, a roadside breathalyzer, investigated driver will breathe into an IR spectrometer, and the amount of ethanol will be calculated on the basis of the amount of infrared absorption. Similarly, in town centres, carbon monoxide, nitrogen, nitric oxide from vehicle emissions is monitored. Again, samples are taken, passed through an IR spectrometer, and the amount of infrared radiation absorbed is used to quantify the concentration of the gases in the air sample. So for my final slide, just the obvious statement that to consolidate you need to practice, you need to find problems from whatever source you have available to you, but those sources which have comprehensive answers are the best. So attempt the problems, check your answers, move on when you are being consistently accurate and complete in your answers. Choose the next topic that you think for you is the one you need to focus on.